Hello, ladies and gentlemen. This is going to be our first unit today. This week. We're going to be talking about basically a review of everything we should have learned last semester. So this is just basically get you guys into the groove. We will have an exam on this, and hopefully everybody's going to do well. So this is what we're going to do today, and we're going to talk about 3 different types of bonding. We're going to review about covalent bonds, ionic bonds, and some other stuff. And then this should take about 10 minutes. And then you got another video over some more stuff that we're going to cover this week and next. So without further ado, let's go. We'll talk about metallic bondings in 3 types. The metallic we're not going to really hit today or this semester. We're going to mainly focus on these 2 types of bonding, covalent and whoops, it's not working right. Where's my pen? There we go. Covalent and ionic. Covalent is basically the sharing of electron pairs. So when we're talking about sharing electron pairs, we've got, like, say, carbon sharing 2 electrons with oxygen, and it may share more than 2. And with carbon monoxide, they're sharing 6. So each line is 2 electrons. And we usually show a little dot structure where they got little electrons, excess electrons. These things are called lone pairs. And we'll talk a little bit more about that in this review, but this is what we want to talk about. The thing with covalent bonds, water cannot break the bonds. That's one thing we need to realize, is that when we look at chemistry, we've got these 2 different types of bonds. Things are going to be, we're going to look in more of the different type of reactions and so forth. With covalent bonding, water cannot break these bonds. We've got to do other things. We've got to actually add energy. We have to have another chemical that can want these electrons to add to it, or remove, add, remove, or try and attach itself to this by, in this case, carbon monoxide taking electrons, but there's other things that can happen. And we'll talk more about those type of reactions a little bit later. But water cannot break the bonds. Now, ionic is when we have something charged, something positive like silver, and it's going to be something negative with silver like nitrate, and these things come together and bond in this interaction. Now, ionic is omnidirectional, meaning that it's in all directions. The attraction is all directions, always positive and negative. Water can break the bonds. Or the interaction between the two charges. So water can come in and break this because water's polar. Water has this nice polarity to it. It means it's got slightly positive on one end, slightly negative on the other, and it can force itself in between these 2 and break them apart. Now, there can be some ionic compounds that water won't be able to do that to a large degree. And we're going to talk more about that after we get through with this review. So ionic, positive, negative, they come together. Water can break the bond, separate the 2. Covalent does not break it. Now, notice with this does not break it. Water cannot break the NO3 apart. It has to stay together because these are covalently bonded. Remember that. All right, covalent molecules do not dissociate in water. They dissolve. That's important. Water, the molecules can be dissolved in water, but they will not dissociate. And most times, covalent molecules contain a non-metal hydrogen. So we look at the periodic table. I'll sketch this out. This is bad, I know, but this is the non-metals on the right side. Metals are all on the left. and hydrogen up here is either both. So when we're looking at covalent molecules, you got to look at the chemical formula and look at what we have. If it's if you got two nonmetals bound together, it's usually covalently bonded, and that water will not separate those apart. It's like PO4. For example, PO4, this is 3-. These things are bonded together, covalently bonded. Now, H3PO4, the hydrogen is ionically bonded. Whoops. Sorry, I pressed it. Hydrogen is ionically bonded. So they can come off the PO4. PO4 is covalent. Now, how do we know that hydrogen is bonded covalently or not? That is a good question. That's something we're going to learn throughout this semester as well, because we're going to look at the chemistry of hydrogen as well as other things. But usually if you know that PO4 is negatively charged, H3 is usually positive charge. That's something I just keep on working with. And we'll talk about acids, what this is, in a little bit later in this semester. I'm going to do a lot of acid-base chemistry. Now, to review ionic compounds, dissolve them. They dissociate in water but do not dissolve. And what do we mean by that is that, say, we have NaCl. Dissociate means they form Na plus and Cl minus. Dissolve means that we got NaCl bonded together in water. So we've got water surrounding NaCl. See, that doesn't happen. And they have to separate. And if we have a cation and anion. And that's what we mean by dissociate and dissolve. Dissolve, the compound remains in one. The molecule remains whole, and it just gets moved into the water phase, and it doesn't break apart. Where dissociation, the compounds actually break apart to positive and negative, and they are in the water phase as positive and negative. This is why tap water is conductive to electricity, because you got all these ions from all these compounds that can carry the electrons. Electrons can only move back and forth. So that's the difference between ionic and covalent bonding. Now, when we talk about names, we don't have the handout for here. Go back to your notes from last year. Cations and metals, and you got a common molecule that forms one cation, NH4 positive. And except for ammonia, this is ammonium. That's the name of this compound. And usually we use the elemental name of the compound. Anions are any nonmetals with negative charge. Hydrogen can be an anion. And then molecular anions is usually from the dissociation of acid. We're going to talk more about that later. But hydrogen comes off and the ion remains together. That's what we need to look at. Now, lastly, in this first part of the review, we're going to look at electron dot structures, the rules. 8 electrons are required for a unreactive set. Electrons can be owned or shared. All right, so they're the rules. The number of electrons are dependent on the number of valence electrons. And we'll talk about which column they in. And we talked about that where we're not looking at 1 through 18, but 1A, 2A, and then 3A, 4A, 5A, what's on the top of the old periodic tables. All right, so those are the rough rules of electron dot structures. And while I'm thinking about this, I'm going to finish this review, and I'll put the electron dot structure as part 3 of this lecture. All right, this is 10 minutes. I'll let you guys go, and I'll talk to you. I'll see you at another slide. Thank you.